I want to thank everybody for coming to this afternoon's session on process optimization for energy and sustainability. So I'm Peter Reynolds. I'm a senior analyst here with ARC Advisory Group, and I'll be moderating this session. So the way we plan on running this is we've got about a 10-minute introduction. We've got two great speakers that are going to talk about their perspective and using tools to optimize energy in a facility. What I'd like you to do is hold your questions until the very end. After we've finished the two presentations, we're going to have a panel session where we're going to offer up a Q&A session and panel for some suppliers of technology and energy and optimization. So we can do this a couple of ways. You can either write your questions down on a cue card, or else you can wave your hand and somebody will bring a microphone and you can ask the question directly. Please silence your cell phones. We are videotaping this session, so it'll be available for playback afterwards. And of course, in terms of safety, please take note of the fire exits over on that side or at the back. So in terms of energy optimization, this is how we see the opportunity. So when we talk about process and energy optimization, we're really looking at opportunities for petrochemical and refining plants. That would be everything from exchangers, process units, fired heaters, and steam and power. So we know that many times process industries suffer from changing operating conditions. We know that equipment degradation leads to suboptimal energy issues. There's fluctuating demand, and there's many times inefficient control strategies. So by looking at steam turbine letdown optimization, heat exchanger fouling program, basic process control system, and advanced technologies, we know that we can do a better job of energy optimization in a plant. So some of the research that many of you, I'm sure, have seen as well, we know that the savings are significant. Fuel gas in a process facility is one of the largest contributors to energy, and 20 to 30% is a typical saving for energy in that space. So we know that there's a desire to operate differently. We know that manufacturing companies that provide sustainable green energy management programs is also affecting consumers who are buying products. Stakeholder expectations are now demanding energy management initiatives, and we're all expecting some form of climate change regulation within the next 5 years. So we know that today there's many problems in plants. There's lots of information available, but there's a lack of information in a contextual format so people can build efficient energy management programs. Technologies that solve problems for energy management, they're time-consuming, they require buy-in from stakeholders inside facilities, and they require long-term buy-in. Oftentimes, the energy teams are siloed from the operations and the reliability teams, and there's a lack of a real-time view in a chemical or refinery today. So some strategies for improving efficiencies. We know that implementation of an energy management program usually involves complex technologies where there's model building and testing. We know that the use of inferential models, controller integration and commissioning, these are all things that take considerable time. And many times before you can even attempt an energy management program, there's requirements to add instrumentation and controls in a facility. Access to good historical data is something that can help improve energy management. But there has been advances made in tools to be able to step test and advance models. Virtualization technologies and deployments are also helping energy management. So other areas that we know that help energy management initiatives, simplifying the tools that are presented to operators and maintenance technicians and engineers in the facility help greatly. And ultimately, the operators who are in charge of the process need to know where whatever solution is taking the facility. Operators need to be understanding where it's going. Long-term sustainability programs. We know that there's issues with graying of the workforce and younger workers that are coming in, and we know that in many cases they don't have the tools of the trade that they require today. Process control also deteriorates over time, as we know. Long-term service and training centers can help alleviate this. Use of centralized and remote services can also help augment staff. In many cases, this is done remotely by centers of excellence, connecting to plants, providing remote model deployment, and assistance with tuning the basic process control system. So many end users are also looking for multiple solution options. So we know that basic process control system tuning and model predictive control tuning is a mainstay application in a large facility, but there's still untapped value in many of the smaller facilities. Some of these are especially involved in energy management. We think it's also important to align programs with cost management and margin improvement. Ultimately, many manufacturers are looking to reduce waste, raw material usage, and low energy costs. Another factor that we think is important for energy management and sustainability is to start small, build an energy team, a center of excellence, and have them as a stakeholder in your plan and decision making of where the operation is going. So really what today is about, we know that energy management is important, but we want to talk a little bit about the tools that are required to help you folks better manage energy. So we know that this energy management doesn't start with an operating plant. In many cases, this takes place in the design phase. Pinch analysis, there's various simulation models and techniques that you can use to optimize the energy usage before a plant is built. Online optimization, a combination of advanced regulatory and multivariable control, and analytics, and advanced tuning programs for the real-time control system. Process monitoring, benchmarks, analytics, inferential sensors, these are all commonplace for energy management.